Okay, another example that we did in class today was number 92. And we had CeIO3 solid dissociates into Ce and 3IO3, 1 minus. Now, in this problem, we were asked to solve for the KSP, and we were given that the solution contained 0.2 molar KiO3 initially. So, remember, when we're doing common ion ices, we don't really care about this because it's a solid, so it doesn't affect. Now, we had 0.2 molar of KiO3. The K is a spectator, so 0.2 is my initial concentration of IO3. Now, since it didn't say anything about Ce, I have to assume that that was 0. My change is going to be that I'm going to put some of this salt in there, and I'm going to add some of the ions because it's going to dissolve a little. Whatever your change is, it has to be consistent. So on the right side, if you add X, you have to add it to both. And if you subtract X, you have to subtract it to both. So I knew that I was going to put this salt in there. A little bit of it's going to dissolve because there was no Ce in there initially. So it's going to have add X, and my E is going to be X, and I will have 0.2 plus 3X. Now, I'm given, I don't know the KSP, and I have some X's here, so that's 2 unknowns. So I have to look back at the problem and see if I know something else. And it gave me that the solubility of this thing in solution is 4.4 times 10 to the negative 8 moles. Okay, that means that the amount of Ce that's going to dissolve is equal to the amount of the whole thing that can dissolve, and the amount of I3 that's going to dissolve is equal to 3 times that amount. So I now know what X is. I have 4.4 times 10 to the negative 8, and I have 0.2 plus 3 times 4.4 times 10 to the negative 8. Now, in these problems, we've been saying that we can probably neglect the X, and I think that that is true for this problem, because if you put it in your calculator, hang on just a second, let me find mine. When you put it in your calculator, you get 0.2 plus 3 times, parentheses, 4.4 times 10 to the negative 8th. Okay? And you see all those zeros? That X is much, 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 much less than 5% of 0.2, so it's pretty much negligible. When we round for sig figs, it's going to go away. So we end up with Ce is 4.4 times 10 to the negative 8th, and I is 0.2 to the third, and you solve for KSP, and you get 3.52 times 10 to the negative 10th. Is the KSP, and that was number 92. Yeah, and we even have to round for sig figs one more time, so 3.5 times 10 to the negative 10th. Thanks.